Hello everyone. Can you guys hear me? Am I audible? Just type S if I am audible. Hey Aditya. Hello everyone. Okay, I'm gonna start in a couple of minutes. Hello everyone. Yeah, I'm so glad that you guys are here for this webinar. I hope you guys doing well in these constraints of the pandemic. I welcome you all to for this event called Arduino Amplified. It's one of the webinar session for the Hacktober 2021. Coming to the Hacktober, it's a month-long celebration of open source software run by DigitalOcean in partnership with GitHub, and ISTE-VIT facilitates in these moments of making one open source mainstream by offering three of its GitHub repositories: Arduino Amplified, in which you can contribute for IoT and electronics, and about Arduino related one. Okay, is there any echo in my voice? Hello, is my voice clear? Yeah, I hope it's clear now. Yeah, Arduino Amplified, in which you can contribute for IoT and electronics and many projects related to the Arduino. And the next one, Projects Archive, in which you can uh, contribute to app dev, web dev, and machine learning. And the third one, the Algo Companion, for which you can contribute to for competitive coding of languages Python, Java, C, C++, Kotlin, whatnot. Also, you can get swags and t-shirt, a free branded t-shirt for 4 pull requests. A top 55,000 members will get that free t-shirt. It will be this Hacktober 1st will go all over the October, in between October 1st and October 31st. You can Your pull request can be a bug face improvement or feature addition or even documentation change. Yeah, it can be anything, and if that been successfully merged, you can get a free branded t-shirt. And here are the proper steps how to register for the Hacktoberfest. Coming to this webinar, I'm Roshan, and I'm here to help with the first step of Arduino Amplified of IoT. This will be the very beginner friendly session about Arduino. So let's get started. First, coming to my this webinar agenda. First, we are going to talk about and discuss about what was the Arduino actually is, and why and how it became famous and most usable board in the world. Next, we are going to talk about particular reference board which was called Arduino UNO and its pin setup. Then we will move on to the Arduino's coding and software environment called Arduino IDE, and we are going to learn about it and many commands related to that. And here is comes the interesting part. We are going to make a some hands-on project which will be helping or maybe your first step towards your microcontrollers. And yeah, coming to the overview. In this overview, we'll talk about the Arduino microcontrollers and what really made them popular among the other boards. Yeah, basically Arduino is an Italian electronic microboard company, and they contribute towards a collab with many microcontrollers and make a stable microcontrollers board PCBs. Not only hardware, they are well being towards the software handling with IDE, and also there are many different boards developed by them like Uno, Mega, Nano, and there's various in pin systems and the microcontrollers and differs in some functionalities also. And this was the Arduino Uno, which was the most reference board released by the Arduino company. Every company releases their products in versions, and the main 1.0 versions will be the basic reference. In the same way, Arduino released this Arduino Uno. Uno means one in Italian, and it released IDE 1.0 at the same time too. and it just costs about 300 to 400 rupees. It's so it's so flexible and easy to program. It's designed such a way that to give a good experience to beginners. This is considered most used boards and standard board in the world. It's because beginner friendly, zero complexity as compared to other big microcontrollers. Yeah, next, coming to the pin setup. This was the board, the Arduino board. As you guys can see, it has a 8 mega 328p microcontroller. Here, the 8 mega is also a series of microcontrollers. Among them, it was the microcontroller used in the Arduino UNO. Then the USB connector for data and software input. Sometimes we usually use this for power input as well. And we know that Arduino needs two kinds of signals. It has two kinds of analog and digital. Then here comes the digital pins. The digital pins on can be configured as either input or output. These are labeled from 0 to 13. It has some negative thingy markings like that. They are actually called not negative marks. Like that was tied sign marks. Those are called PWM pins. PWM stands for pulse width modulation, which is method to control average power supplied by the electrical signals. It is a method. Yeah, it can control the digital outputs to control the analog devices actually. Basically like which stimulates an analog output like fading an LED in and out like that. We can use their PWM pins. And then here comes the analog pins. These are named from A0 to A5. This can read the signal from analog sensor like temperature sensor, gas sensor, like that. Although these named as analog pins, analog input by default, but these pins can also be used as digital input and output. And here comes the power reset ground pins, which has 5 volt, 3 volt, and 2G and ground pins, and one V input, which can V input can be uh, used as a power source. Like can add a power source into that to power the Arduino. Then here comes the reset button. When this button was clicked, it actually sends a logical pulse to the reset pin of microcontroller, and it runs the program from the beginning, from it starts the again. This helps in testing type of that. Then here comes the barrel jack, used to power the board with an external batteries power port type. So these are TX and RX LEDs. TX stands for transmit and RS stands for receiving. These are like indicators, and they blink when it's transmitting or receiving the data. Yeah, then the voltage regulator, and it has some USB interface chip too, like here it will be. This is like a signal translator. This translates the USB level data which we got from the programming source. Then it will convert to the atmega level of data. Then now coming to the software systems, like software exposition. The software system of Arduino, known as Arduino IDE, integral development environment, containing a text editor for writing your programs, and a message area, and text console, and a toolbox, serial monitor, whatnot, where you can see the output and your gettings which you're being programmed. It uses mainly it uses a subset of C and C++. And like, wait, I'm gonna show it how to download the Arduino IDE. I guess you guys can see my Chrome browser. Yeah, this was the website, arduino.cc software. You guys can check it out in the description and in the chat box as well. This was the Arduino. The latest version is 1.8.6, and they released the beta version of 2.2 also. Just go here and click in the Windows. No need to do support. Just download. Then next, yeah, it will be downloaded anywhere, and just install it once. Then after you open it, it will show it like this, like the screen. Yeah, this one's verify button, which verifies your program, and this will the upload button, which will be upload your program to the Arduino board. Not only Arduino board, the IDE can be uploaded to many ports as ESP8266, ESP32, like that. We usually connect a hardware setup to one of the communication ports of our laptop. The communication happens in the particular communication protocol, and you can see these are like file, new, open regions, and many options were there for save and examples. And in the sketch, you can verify and upload, and there was an option for include library. You can add many boards and many sensor libraries, like a servo is not a sensor, it's a motor, servo motor. You can add more many libraries for you, which can less your work, like decrease your hard work in the programming. And then coming to tools, uh, yeah, it will show the boards which you're connected, like board Arduino it will show as a default. And you can see the port as well. If you connect to a Arduino board, it will show a port connect to your like COM5 COM6, like that. Then these are the bootloaders and auto format, and it's an open button, it's a save button. Yeah, this was like wait, I'll zoom it. Yeah, when you guys open an sketch, like this will be called as a sketch. Open new file in IDE, you can see these default codings, like here a word setup has been written. You guys, as you guys know, this void is a command which helps to declare functions, and setup is a function, and a loop is also a function, in which setup in which here whatever you write in the setup, it will run for once, and in loop, whichever you write will goes on repeatedly, run repeatedly as long as it runs. Yeah, like here if you keep two double slashes, the Arduino will not consider those lines. Obviously, the program which we will write in here, it will be a case sensitive one. And coming to first setups, uh, variables, initializing the variables, like these are usually used variables are used to store info or data to be a reference or manipulated in program, like data type and variable name equal to the value. Yeah, the data type can be an int or an or character or some string, and ints were used normally for the integers and characters for the strings as well. And here for example, if you can write int val equal to 10, here after every statement we have to put this semicolon over here. And also if you like just initialize like that, the Arduino will take automatically a 0 will be stored initially in that, and we can change that inside a program with recursions and all. So the question comes here that why I was writing that initializing there but not in the void setup or in the void loop. First, you have to know a global variable and the local variable. Global variable will be whole for the whole program. You write will you will be writing for whole program when you use that global variables. You can be used that in the outside of the whole void functions. If you want to write in only if it want to be in a particular function in the setup, it will be called as a local variable, and it will be only particular only for this setup. It will be constrained till that only. So okay, coming to the main commands for the Arduino IDE, you can control any digital pin from the IDE. Whenever we use a UNO pin, we have to assign a role for that, and pin like how it's working, and is it working as an input or output. So we use it as pin mode. Yeah, it's a case sensitive one. If you write like pin mode like this, it will not consider it as a command. Yeah, pin mode, and you have to write a pin like here, and if it's working as our input or input, then output as output. Yeah, like pin, if you use a pin number 2, you have to write like pin 2 output. Mainly like it will it if you write pin mode, it's a case sensitive one, where like this output stands for, yeah, yeah, here this output stand for sending a data, like sending a 5 volts to a particular pin, and input refers to the receiving a data like that. Okay, so then coming to another command called digital write. It will be for the digital uh, pins. Digital write, we can send the two types of signals out of Arduino, like an output device like an LED or something. Those two will be high or low. Yeah, like here also we have to assign a pin, and we have to assign is it working as high or low. If it's high, then the it will send the 5 volts or voltage to that particular pin, then the LED will glow. If you give a low function over here, then it will give a 0 volts and it will turn off like that. And another one, here comes the delay function, like delay whenever we need to pause our program for some time, we use it. uh, uh, that time you'll need include should be in this time will be in milliseconds. Like if we like 1 second, we want 1 second, we write delay and 1000, it will count as 1 second delay. And then one of the most important tool, which is the serial monitor, uh, here, which is used to see how the serial communication was happening. To understand the serial communication, let's take the which has D0 and D1 digital pins, which are called as TX and RX pins. Those both use UART communication for data transfer. UART is called serial communication in this Arduino. A simple way to know what's UART: for any sensor, it will have TX and RX pins. Those TX and RX will use UART communication protocol to communicate transmitter pin transmit to receiver, and will and vice versa to the receiver to the transmit. transmitter. So this serial communication, these two were directly connected to the USB port, which we use for uploading the code to Arduino, So serial monitor is the tool that we can observe the communication over here. And for the Arduino UNO, you can see the baud rate will be 9600. It is used to initialize, yeah. Then another serial, to start a serial communication, we use this serial dot begin, and serial dot begin with the baud rate added with that. So it will start the serial communication. We use it once, so we write it in the setup. 9600 will be the baud rate. It's communication speed in units of bits per second. So if I write 9600, it will communicate it in 9600 bits per second. It differs per devices. So I think you guys, for going more deep into serial communication, I'll take an example. Wait, I'll erase this all. Yeah, I'm just starting the serial communication now. Serial dot begin 9600, and then uh, in the void loop, I'm just initializing a character called val, which gonna read the serial communication, or what is happening in the serial communication. It's read that. This was the command used for reading the serial communication, and then serial dot print. It's usually used to print the commands which we got in the, like, print the output data or the communication happening, which is happening in the serial communication. We can print it on the serial monitor over here, and we're gonna print this val and semicolon, and let's see what gonna happen. Yeah, don't forget to save it. Yeah, it's uploading here, compiling sketch, and you can see the loading thing happening. I connected my Arduino, in the communication for COM4 of my laptop. Yeah, it's uploading. Yeah, it's done uploading. Let's see what we got in the serial monitor. Yeah, like you guys can see the garbage values. Like here, it's printing the very garbage values. Over here, we can see some very garbage values. Why is this happening? Means the thing is, we directly wrote character val serial read one over here. So these there we haven't sent anything, so nothing assigned to a val. So it's reading serial communication as some garbage values before, and it's just directing printing it the uh, garbage value. So in order to take that, in order to cross that problem, I'll add an if loop. If serial dot available, if like, if it's available, yeah, is equal to 1. If it's available, then it will read the character, and it will send the data, and it will print. Let's see if it works. It has to work. don't forget to close the bracket. Let's upload. Yeah, it's uploading. Done uploaded. Let's clear the output. Yeah, you guys can see now there's no garbage coming over here. Let's press K. Yeah, it's outputting what we Y, then J. Yeah, you can see if I type anything, it will read the communication and it's printing in the serial monitor over here. Yeah, like I guess you guys understood well about the serial communication now. Okay. So forgot to tell that we have another important command for digital pin, digital read. It's a digital read command. It reads the value from any specialized digital pin, either it's high or low, or that means 5 volts or 0 volts from a sensor or button device can send. Okay, like digital read pin like that. Just as digital write and digital read, we have also the same commands for the analog pins, analog read and analog read and analog write. So analog read, we can read any data which gets from the analog pins. There are some sensors which send only analog values like gas sensors like that. It can give only in between 0 to 5 volts. It can send the data between 0 to 5 volts, like it can use 1 volt data and 3 volts data like that. It can be anything. So we read those values. And you guys have to remember that analog pins can't be able to write. So we use the digital pins in order to write analog output. Yeah, here we get like we use the PWM pins for the analog write, which are 3, 5, 6, 9, 10, 11, which was showed before in this session. Analog write works under these PWM pins only. We can output a value in between 0 to 255, which means 0 to 5 volts. Yeah, like analog write pin comma the value, like between the value, like let's say 200, and it will give the, like, if LED connected to a 6 pin of a PWM, and if I type a 200, then it will glow a brightness of LED with medium. If I press like 100, then it will glow like low medium like that. If I press like a 15 or something, which is so dim, and if I press like 255, then the LED glows with a brighter glow, which is its maximum capacity. So these are the basic commands we use. We need to write in every program. So this would okay. Now let's move on to a mini project without any waste of time. Now we are gonna make a automatic door with Arduino UNO. We use a ultrasonic sensor for that, and of course Arduino UNO and a servo motor. In order, you guys have to know about the ultrasonic sensor first. Okay, it's quite simple. The TX pin of this emits the TX pin emits a ultrasonic sound at 4000 hertz, which travels through, and if there's an object or obstacle over there, it will bounce back and will read by RX of it. And you can see that ultrasonic has VCC, trick pin, echo, and GND. Uh, we'll go to the hardware next. First, we'll understand this ultrasonic wave work. And first, you need to to set the trigger at high at 10 microseconds at highest stable. Then it will send out 8 cycle sonic burst. Like it will send a ultrasonic sound, and right, 8 sonic burst. Then which travels with the speed of sound, and it will be received with the echo pin. So the speed of sound will be 340 meter per second, converting into a centimeter per microsecond. It will be 0.034. So we usually, what we're gonna do, like if a person uh, come comes to near the door, this ultrasonic will gonna detect the distance, and it will send to the Arduino and Arduino will send to the servo motor to open the door. Okay, that's gonna actually gonna happen in this project. So we need to we use this ultrasonic sensor to calculate the distance here. So in order to calculate the distance with the speed of sound, we use this formula called S is equal to TV, which gives the distance. Here, why we use TV by 2? Because the sound goes and comes back. So in order to get it will give a double distance which the sound wave traveled. So in order to get accurate distance, we divided it by 2. Like its speed is 0.034 centimeter per millisecond. It will give t into 0.034 into 2 in centimeters. Okay. So we start with the software. Let's code the program. Then we'll go to the hardware and so on. Okay. Okay. So let's open a new sketch. Okay. To work for the uh, servo motor, we need to include a library called servo.h. Go to a manage library from the sketch. Wait, it's loading. Yeah, from that you have to download the servo.h from the libraries manager. Yeah, it's loading. It's downloading update. Yeah, from here search of servo.h and just install it. You get that library installed in this Arduino servo.h. Yeah, so this just install it and just include that library with hashtag include. Servo.h. Then we're gonna we have to connect this trick pin to any digital pin. So I'm connecting it to, let's say, 12th pin, and then we need to connect this echo of PWM as it PWM pin as it's receiving an analog data. So int echo, let's initialize it for 11, which is a PWM pin. Then we need to name our servo. We'll name it as my servo. Okay, semicolon. Then we need to find the duration first, like time which can read from that echo pin. Then we need to calculate the distance. So I'll use long int, which is used for long integers, and long int duration. Then I'm gonna initialize distance, which these both are initialized as zeros initially. Okay, so we can change it with the values we got. Coming to the setup, as we know that pin mode, we have to keep this trick pin trick, as this trick releases the ultrasound wave, we keep it as output. Then we'll initialize the same way for the echo, and echo receives the reads the data, so it will be the input. Okay, input. Then we'll have to attach this servo dot attach. Let's say I take a ninth pin. Okay, this will be the pin initializing for the servo, and then we'll start the serial. It's the most important one. Serial begin in 9600 baud rate. Yeah, now we completed this initializing terms. Then we'll come to the important main part, void loop. So at first, the digital write will be at low for the 2 microseconds. Then it will go to the 10 like high for the 10 microseconds. Then it will go off low after that. So we'll do that here, like digital write trig low for, I'll give it delay, like it's an exclusive command for the microseconds, delay microseconds, like 2 microseconds. Then I'll keep it high, digital write trig high for the 10 microseconds. 10 microseconds. Then I'll make it 0, as we saw in that graph before when I'm explaining that working of ultrasonic. Yeah, then these things will be release an echo ultrasonic, triggers the ultrasonic sound wave. Okay, then we need to reads the echo pin, reads through the echo pin, which that sound wave really reflected from an object. So we uh, we need to get that time right. So duration is equal to the pulse in, which is exclusive command for this echo for to read the time in microseconds for the echo pin, for how much time it traveled. So echo slash high, so that it will read the data. Then we'll calculate the distance with the formula used. Distance is equal to duration, the time, into 0.034 by 2 centimeters. Okay, yeah. Then we'll print this distance initially to get how much distance the object is. It's will be displaying it in the serial monitor. Distance. Yeah, it will display the distance. Then these the ultrasonic detection part is over. Then it will the microcontroller, it works on the distance, and it calculates if it's near or less than the, let's say 20 centimeters. So if it's like less than 20 centimeters, then the door will open, or else it will close. Okay, so I'll add an if loop. If distance less than 20 centimeters, then it will print like you can enter like that. You can enter. Oops. Yeah. Then the door has to like open. Here the door was a servo motor, so the servo motor has to rotate to a 90 degrees or 100 degrees, let's say. So my servo, which was its name, servo.write, which is used to special command to give an input to a servo motor to move that angles like opening after opening and closing. Let's give it 100 degrees for open and let it be open for 4 seconds. That means 4 milliseconds here in the delay command. Then we'll close it. Okay, so try 0. It will open for 4 seconds. After the person enter, it will close. After 4 seconds, it will close. We'll close this if loop. Then we'll add else if nothing detection happen. Then it will say like 0.print ln, which the ln is used for like printing of your data in a line wise after line by line. Like we can print like you are not close. Yeah, you're not close enough like that. Okay, semicolon. Then I'll give a delay so that it works fine, like without any much displaying data doesn't happen and a clumsy doesn't occur. Okay, I'll close this and I'll close the whole wide loop one. Okay, it was closed before. Okay, yeah, this will be the program, whole program for this automatic door. Okay, we'll click this upload button. I already connected it. Save it. See, it gave an error. Yeah, I have to initialize my server. Yeah, sorry. We're gonna keep my server, our server, one over here. We'll compile it. Oh shit. This was the blunder. Okay. These things will happen every time whenever you program a thing like this. Sometimes, like if you're very perfect in coding, you'll never make a mistake like these blunders. Yeah, it's uploading successfully. Okay, it's uploaded. So I'm gonna show my screen now. Coming to hardware, I guess you guys can see my uh, cam. Yeah, this was the ultrasonic sensor I used, and this was the servo motor. And you can see this is the Arduino, and this was the port which is connected to my laptop. As you can see, I was connected this VCC to a 5-volt one here. I connected this servo and ultrasonics one to a 5-volt in a breadboard. You guys know how breadboard works, I guess. Then I connected to a VCC to a 5-volt pin. Then I gave this trick. One goes to the 12 pin here, and this echo pin will goes to the 11 over here. Then the servo signal pin will goes to the ninth over here. You guys can see, right? Then the both grounds of this ultrasonic and the servo motor goes into here. Okay, these are the ground pins. You guys can see, okay? Yeah. Okay, let's test it out. Open my serial monitor. You guys can see, I guess. Yeah, you guys can see the distance. If I distance is 3 and the motor was turned, you guys can see. I went back, closed. Then I'll go near. It's detecting. Yeah, it's 4 and it's open. I'll go and it's closed. Like that, it will be the automatic door div project, which you can do uh, for any project or something, and it will be the start for the IoT, and it will be the start for your microcontroller programming. I guess we came to an end of this session. I hope this session will be your nice beginning for your journey towards IoT. I hope you guys enjoyed it. So start your journey by contributing to the repositories, to the links given below in the description, and win a free t-shirt if you guys were lucky in the 555,000 Arduino Amplified project archive and the Algo Companion. And this is my name, Roshan Teja. You guys can connect with me anytime for anything, absolutely. And I'm gonna thank my design team, our tech head, Mr. Hardik, for giving me this such a wonderful opportunity for this session. And I want to thank, of course, ISTE for giving me a platform like this. And also, I'm gonna thank you guys like listening patiently for last past 50 minutes. And here are our social handles. Follow them for such great, insightful information. Thank you all, and we'll meet you in GitHub. Bye bye, and don't forget there's a link of a feedback form. It will really help our improvement as negative or positive, either negative or positive. It will give more effect on us. So please don't forget the feedback form. Also, there's an attendance form in the chat box. Fill it as also that well. Okay. See you then. Bye bye. Yeah. Thanks.